So in this example, we're going to use our calculators to run a hypothesis test on a standard deviation. A bottle of soda is supposed to contain an average of 68 ounces with an error of 1.9 ounces, give or take. A sample of 45 bottles is found to have a standard deviation of 2.4 ounces. Does this mean that the bottles have a greater variability than advertised? So let's do our hypothesis test. Our null alternative. So the null hypothesis is going to be that this sample has the exact same error as the normal bottle, which is 1.9. And we're testing, does it have a greater variability? So that would be, is sigma greater than 1.9? So we're testing this at alpha equals 0.1. And we had a right tail test because we're greater than. So that means that 0.01, that 1%, is going to be on the right-hand side, which puts 99% here. So we're going to use our calculator first, find the critical value, which tells me whether we reject or not reject. So it's always the area to the right, so that would technically be 1% or chi-squared 0.01. So let's go to our calculator, go to Program, chi, and the degrees of freedom is 1 less than the sample size, which in this case is 45, so that's going to be 44, and the area to the right we have written as red 0.01. And we're going to get our calculator second to do this. All right, so we get a critical value of 68.71. I'll write this underneath. So this will tell me whether we reject or not reject. And remember that to the right, the small area is always our rejection region. Okay, so calculating our test statistic, chi naught squared, which in general is n minus 1, s squared over sigma squared. In this case, it's going to be 45 minus 1 times s, which is 2.4 squared, all over 1.9 squared. So we throw that into the calculator real quick. And that gives us 70.20. Do this in purple. So where that falls is, looking at my test statistic, this falls to the right, 70.20. So since it falls to the right, we fall in the rejection region, so we're going to reject H naught. So our conclusion is we do have sufficient evidence to conclude that the variability is greater than advertised.